Assalamualaikum. We are from CBCS 1434C. We will explain Chapter 3, Velocity and Acceleration about projectile motion. What is projectile motion? A projectile is any object thrown into space upon which the only acting force is gravity. The primary force acting on a projectile is gravity. This doesn't necessarily mean that other forces do not act on it, just that their effect is minimal compared to gravity. What about projectile motion? Projectile motion is when a particle is thrown obliquely near the Earth's surface. It moves along a curved path under constant acceleration directed towards the center of the Earth. The path of such a particle is called a projectile, and the motion is called projectile motion. In a projectile motion, there are two simultaneous independent rectilinear motions, which is along the x-axis, where uniform velocity responsible for the horizontal motion of the particle, and along the y-axis, where uniform acceleration responsible for the vertical motion of the particle. Determine the speed at which the basketball at A must be thrown at the angle of 30 degrees so that it makes it to the basket at B. Now, let's move to the problem solution. From the diagram, given the ball's angle at point A, gravity, and the displacement of the x and y components. By using the angle, we may get the value of the initial velocity u. Firstly, we need to know that the y component s has a displacement of 3 meters between the ground and the ball at point B, but the ball's displacement from the point A to the ground is only 1.5 meters. So, let S1 equal to 3 and S0 equal to 1.5, where S equals to S1 minus S0 and equal to 3 minus 1.5. Then we will get value of S is 1.5 meters. We can create two equations by inserting the values from the x and y components into the formula S equal to ut plus 1 over 2 gt squared. Then, simplify for both equations. Since there are two variables in this equation, we will use the substitution technique. After substitute equation 1 into equation 2, we will get u equal to 12.4 meter per second and t equal to 0.9312 seconds.
Second question, the boy at A attempts to throw a ball over the roof of a barn such that it is launched at an angle 40 degrees. Determine the minimum speed of VA at which he must throw the ball so that it reaches its maximum heights at C. Also, find the distance of D where the boy must stand so that he can make the throw. From the question, when the ball is thrown to reach the maximum value, we can assume that the velocity is equal to 0. Therefore, the minimum speed of VA is 0 meter per second. Next, we need to find the initial velocity of y and x component. The question has given the height of the barn, which is 8 meters. Since the ball is thrown 1 meter above the ground, the maximum height of the barn is 7 meters. By using formula for y component, v square equal to u square minus 2gs. Substitute v equal to 0, g equal to 9.81 and s equal to 7. Hence, the initial velocity for y component is 11.7192 meter per second. To find the initial velocity of x component, we need to find the initial velocity, which is use formula u sin theta equal to uy, which means initial velocity of y component. By substituting it will get to know the initial velocity is 80.2319 meters per second. From that, we get to find the initial velocity of x component. U cos theta equal ux. The initial velocity of x component is 30.9664 meter per second. To find D, we need to know the time taken. T, the ball has been thrown. By using the formula for y component, V equal to uy minus gt. Substitute all the value and we will get 1.1946 seconds. Lastly, we get to find d by using the formula of x component, which is s equal to uxt. Substitute the value s equal to d plus 4 ux 30.9664 and t is 1.1946 and the d will be 12.6843 meters. As a conclusion, from all the examples that have been shown, by studying projectile motion, we can involve an object moving through the air under the influence of gravity. Other than that, we get to know the motion of the freely falling body in the vertical direction and uniform motion in the horizontal direction with constant velocity.